We have seen the graphing method for solving a system of equations, and it's great. It's always going to work. We're even going to use it in other methods to check our answers. But there are other ways, and sometimes, depending what you're doing, one of these other ways might be easier. The first we're going to look at is called substitution, and it works like this. Here are my two equations, and I want you to notice that in this top equation, I've already got one variable by itself. We're being told, hey, this y that we're looking at, it's equal to negative 5x plus 23. Here is what we're going to do. Follow along with me on your own paper. I want to take now this other equation, this bottom one, and where I see an x, I'm going to leave it as an x. But where I see a y, I want to put some big empty parentheses because we're going to put something else in those empty parentheses. Now notice everything else is the same. 5x plus 5y, that's what these big empty parentheses represent, equals 15. That's just the bottom equation. It's called the substitution method because we're going to replace this letter y with something y is equal to. If two things are the same, then you can switch one out for the other and you still have a true statement going on. So where we see this second y, let's replace it with its equivalent expression from this top equation, negative 5x plus 23. This is an important thing to understand because y is the same thing as negative 5x plus 23. In the other equation where I see the y, I can replace it with negative 5x plus 23. If we do that, there's a benefit. Now my equation has only x's. And if there's only one variable, then we can find the number that makes the equation true. Let's now simplify and solve this equation here in blue and red. See what happens. The 5x in the front is going to stay the same. When there's a number times parentheses, distribute that number through the parentheses. So 5 times negative 5x and 5 times 23. Now I'm reasonably sure I know what that is, but just to be safe, I'm going to double check on my calculator. 5 times 23 is 115. So plus 115 equals 15. Now here's a point where students often make mistakes. Right now, I've got x's that are on the same side of the equation. Just put them together like they look. 5 minus 25 should leave us with negative 20x's. Very often, you're going to be tempted to start doing opposites. You don't want to start doing opposites or inverse operations until you are here. This is now an equation that we can solve. So let's get the x by itself. That means I want the 115 to move to the other side. Negative 20x. 115 minus 115 goes to 0. 15 minus 115 is negative 100. And then let's do a division by that negative 20 to finish off. And just like that, I've got my x equals negative 100 divided by negative 20 is positive 5. Whew, that was a lot of work. And I wish we were finished, but we're not quite. Because the solution to a system is two numbers. It's an ordered pair, the x and the y. So here's my advice. Let's take this number for x, go back to this equation that already has y by itself, and we're going to do a substitution one more time. Except this time, y is the number I don't know, and where I see the number x, I'm going to leave some empty parentheses. So y equals negative 5x plus 23, because we know what number x is. That's what we already found. Simplify. Negative 5 times 5 is negative 25. Negative 25 plus 23 is negative 2. So the solution to my system, at least what I think it is x is 5 and y is -2. Just to be sure that we've done things right, let's check it on a graph. So let's graph the top equation, and when you're checking your answer, always go back to the equation you started with. So y equals -5x plus 23. And then down here, 5x plus 5y equals 15. I hope these cross at the ordered pair 5, -2. And sure enough, they cross at the ordered pair of 5, -2. Okay, let's fill out our toolkit here with this example. So as we go through, pause as you need to work through the steps on your own and to make sure that you're not getting behind. First step, solve one of the equations for one of the variables. That means you want this. You want a variable, either an x or a y, to be by itself. We already have that. So in this case, the first step is already done. Step number 2. We're now going to take this expression for y, go to the other equation, and where you see the letter y, replace it with the equivalent expression, the 2x minus 4. So substitute into the other equation so we can get a number for the first variable. Here's the first place that I would like you to stop and to pause your video. Replace the letter y with the 2x minus 4. And now I want you to solve this equation, get a number for the x, and unpause when you're ready to check your work. Hope you did that. Did you pause? Ready to check your work? So distribute the 3. 3 times 4 would be 12. These x's are on the same side of the equal sign, so just put them together like they look. 8 plus 6 is 14 x's. Now I'm ready to do some solving. So add the 12. That's going to leave me with 14x equals 14. And then to finish, divide by 14, divide by 14. X is 1. Nice. Now step 3, because I've already got a number for the first variable. Substitute once more into the other equation for the other variable. So you can actually use any equation. I like to use the one where the variable is already by itself, because I want to find what number y is. So forgive me here, I'm out of space. So I'm going to draw my arrow and come over here to continue my work. Y equals 2 times x. But here's the thing. I know what number x is now. That's what we just found. Okay. So now y equals 2 times 1 minus 4. Well, 2 times 1 is 2. 2 minus 4 is -2. So my solution, my ordered pair, is an x value of 1 and a y value of -2. Final step, check it. We've got our Desmos graphing calculator available. Let's make sure that the solution we got is what the solution should be. 8x plus 3y. Going back to the original equations as they looked when we started, there's number 1. Y equals 2x minus 4. Where do they cross? At 1, -2. We're in good shape. If ever your solution doesn't match up, then take a look at your work, see if you can find where the mistake is.